So my name is Chris Bono. I'm a software engineer on the Spring team at Broadcom. And today we're going to go over the introduction to Spring gRPC. I won't read all the disclaimer out for you, but and we're going to do a high-level overview of Spring gRPC, do a few slides to go over, and then we're going to jump in and do a live demo, so hopefully show how easy it is to use Spring gRPC. So what is gRPC is a high-performance polyglot RPC framework, and it is interesting. We use protocol buffers to define both its IDL and the message format. And a typical layout will look like this, where you have, first off, you have a gRPC server, and then with the server, there would be bindable services or services registered with it. And then you can see the different clients, they all communicate through a stub. And so the Ruby client, for instance, the stub is obviously in Ruby, and then you have one for Java as well. And it just sends the proto requests back and forth for the request and responses. And gRPC Java is one of those polyglot implementations. It's the Java-based implementation of gRPC. And Spring gRPC we basically provide Spring-friendly abstractions that use gRPC Java and make it easier to use. It consists of a core library and then a bunch of Spring Boot auto configuration. And this brings gRPC into the Spring ecosystem. Up until this point, we had a gap there. There was no really, gRPC is a widely used framework, but there wasn't any Spring support for it. Some of the features we bring is everything's auto-configured. So we have Spring Boot auto-configuration around the clients, around the servers. And there's multiple server choices. You can use Netty, shaded Netty. We can also run the gRPC server inside of a servlet container. And as well, there's also support for an in-process server, which is useful for testing. Another thing we do is gRPC itself has a built-in health system. And when the service is down, the clients will automatically not try to contact the service. They all participate in the health system. One thing that's cool is that Spring Boot also has the concept of a health system, and with a Spring Boot actuator. So if I have a Spring Boot application, I will probably set up my health indicators for, say, if I have a database or a Mongo database. There's a bunch of health checks for individual components. And so what we do is we can hook those health indicators into the gRPC health system so that you don't have to go and write a health check for, say, a Mongo service that's running on your gRPC server. It'll just automatically hook in to the gRPC health system. We'll demo that today as well. We have support for GraalVM, which will make a server startup faster and smaller. We also have built-in observability and metrics, as well as Spring security. So if Spring security is on the class path, you can use the typical constructs to secure the services. Let's see. And why? Why do we want? What's the benefit of Spring gRPC? There was, like I said before, there's no officially supported Spring representation for gRPC up to this point, and there's several projects and starters out there that people are using, but nothing's really officially supported. And so this will give Spring users the long-term support as what they expect with any other Spring project. And ultimately, the reason to use it is increased developer velocity and experience. Cool. And currently it looks something like this. The version number right now is O.X. I think we're at O.10 right now. And it's out of experimental status, but we haven't done a 1.0 GA yet. And right now, if you look at the project, we'll have core and the auto configuration all exist in the Spring gRPC project. And what it will look like next is we're moving the auto configuration into Spring Boot 4.x so that it'll be just similar to other Spring projects that are auto configured. And that's it for the slides. Let's switch over and do some demos. Plenty of time. Cool. That's not me. Oh, there we go. All right, let me get a little civil water here. So this is a Spring Initializer. It's not part of Spring gRPC, but it's a great place to get to bootstrap your Spring Boot applications. And so here, if we go to start.spring.io, I'm going to pick Java, Maven, Spring Boot 3.5. We'll just use this default names for a common example demo. It's going to be a jar packaging, Java 17. Let's just add gRPC. And if we explore this, we'll see that there is a POM created. The main piece being that it's using the Spring gRPC Spring Boot starter. There's some other dependencies added as well. I'm just going to go ahead and download this. And what we're going to do is we're going to create a server, a Spring Boot application that's going to be the gRPC server. And then we'll create a simple service that's going to take a user and register it. It's not going to save anything. It's just going to show how we pass those requests and responses back and forth in the server. And what we'll do is once that gRPC service is up and running, we're going to use a tool called gRPC curl, which allows you to do like curl semantics. You can contact the gRPC service just like you're using curl. And then what we'll do is we're going to create a separate application that's going to be just the client only, and it won't be using gRPC curl. We're going to create a gRPC client, show the remote communication, and then what we'll do is hook it into the health system, and then we'll see that when our health goes down on the server side, that the client respects that and doesn't try to contact it. And then if we have time, we'll show how to run it in a servlet container as well. Cool. So I've downloaded the zip file, and I'm going to unzip it to this directory. Downloads demo.zip. Demo. So, see if y'all can see that. Okay. Let's go to idea. Still a little bit. That's still pretty hard to see, yeah? Let me see something here. So the first, you make it a little bit bigger. The first thing that we're going to do is we're going to define the service and the request objects and response objects in a protobuf file. So let me see. I've got this live template selected that we can, so you don't have to watch me attempt to try to type all this out. So you'll see right here, here's the user service, and this is the RPC. We're going to create something called register user that's going to take a request and then return a reply. Some of the objects, these are the messages that we'll have back and forth. This is user info, and it's going to have a user ID and a username. A registered user is going to have a user info plus some tier, like free, basic, or enterprise. And then this is the format for the request and the reply. You'll pass in a user info, you'll get back a registered user. So that's simple enough, but what happens if we come over here to our Maven package, we run that. What it's going to do, there's a protobuf plugin that's going to go inspect that file and then ultimately generate a bunch of Java objects for us. If we look here, yeah, and here they are. Let's see if y'all can, that's pretty small. Hopefully that's legible. But what we have here is let me mark this directory as generated sources, so IntelliJ finds it. Let me see. Generate sources root, okay. Repackage one more time. Okay. So now what I can do is come over here to this. I'm going to create a user service. Now, so I'll show you that the protobuf generator actually creates a bunch of code for the user service, but we actually have to go and implement what we want the method to do. We're going to have this register user that we need to actually do something with. So if I come over here, I'm going to make this a service. Wait, what's going on here? Oh, this is strange. Release version 5. I don't know how this happened. Let me see. Yeah, not 5. Okay. Okay. What is going on here? What's that? Do I have what? Yeah, it should be in the starter. Spring Boot, right there. It's included from the Spring gRPC Spring Boot starter. This is very strange. Open module settings. Okay. Okay. Let me just do this here. What in the world? There we go. Okay. Thank you. That's all there is to see, no? Okay, so the first thing we're going to do is implement user service gRPC dot user server umpel base, okay? And what you can see is if we override this method register user, see if this is visible to the other. Okay, yeah. So if we jump in here real quick, you can see that there is some stub code generated, and it's server calls, async, unimplemented unary call. So it's not going to do much of it by itself because it doesn't know what we want it to do in the register users. Now we'll go fill some things in here to make it register a user. Logger. Log equals. I'm going to do this. I know I need this for part of the demo here. This is not really typically how we'll do random things here. So, new random. Okay. Okay, now let's go down here. I'm just going to log some that we're doing some user registration. So if I say var registered user equals register user builder set user request.get user set tier We'll define the tier down below and build. And you'll notice that the registered user, those objects, the protobuf generator creates a builder for each one as well, so that's helpful. And if I come down here, let me create this enum real quick. Tier, and then we'll have free, basic, and third time, okay. Enterprise. Hold the caps button. Oh my word. Enterprise. You can do it. Okay. Now what we want to do is, let's see, log gRPC log registered user, and then now we'll say var reply new builder dot set registered user dot build. And then we will, there's a response observer, you just say on next, and you say the reply, and then response on observer on completed. This is a super simplified version of an implementation. Typically, you'll have also some error handling if you would do an on error versus on next. But at this point, we have a method that's going to take the user info, log it, and then just reply back with the user response, with the registered user. And so if we come over here and run, let's see what we get. Yeah, you'll see here, you'll notice, so registered gRPC service, so it registered our user service, and then also it registered this server reflection service, and then that health service I was talking about. And it looks like it's listening for requests on port 9090. Okay, so if we come over here to, I'm going to use this gRPC curl. And if you can see that, it's so small. I use gRPC curl to hit an endpoint called list. And what that does is shows you all the services that are, using that reflection service, it shows you what all the services are running on the server. And then you could further inspect things like, for instance, describe the user service. It says user service as a service, and it shows you the RPC, the request and the response. But this can be helpful, and there's other tools that allow you to go in and look and see what all services are running. You can go further and dig into the user service and have it describe even deeper what the payloads look like in and out. And so we can also use gRPC curl to invoke that service. So here I'm going to call the the register user method on the user service and passing in some user info. And I did not, this. Let me see there, I think it's, okay. Okay. All right, there you can see we called, returned back a registered user with a enterprise tier. And if we go over to the log, the output, you can see that it's logging that, it invoked the method and it returned back a registered user. Okay, so nothing too shocking there. So what we want to do now is let's come back over here to start Spring IO and let's close this. What I want to do is create a demo client app. We could do this in the same server, but it's a little bit better. I think it's less confusing if we actually have two apps, one for the client, one for the server. So we'll call it demo client. We'll have gRPC as a dependency. Let's also add web, because what I'm going to ultimately do is curl the client through a REST controller, and then it will invoke the service remotely. So here, let's generate that. We'll come back to here, unzip, dash directory here, downloads, demo client, there, cd demo client. Do this, clean install script test. There's no proto file, so the compiler was complaining. So let's, just like we did on the server, we need that proto file here so that we can generate our stubs. and it's an identical representation of what we had before on the server. We don't want to run a server here, and so what we'll want to do here is specify some properties to tell it not to start the server. Application YAML. And we'll say spring.gRPC server enable false. Okay. So let me come over here and run the proto compiler again. Okay. We have our stubs created, generated sources, protobuf. Yep. Cool. Run it again. Okay. So what we need to do here is similar how we had the service and we had to implement the service method. There's the user stubs, the user client stubs are available. You just need to bind them to it, what we call a channel in gRPC. And so let's come over here to our demo client app. And let's gRPC manual clients. Let's see this one here. So here we have, so we'll have this gRPC channel factory is auto-configured, and that's what we use we take a channels and we create a channel and ultimately pass it into this stub method, which takes a gRPC channel. And so what we want to do here is give it a little bit of information, a hint about where that gRPC client, where that channel needs to communicate to, and we'll say channel is user, it'll be our user channel with an address of static, all in localhost 9090. Okay. And so at this point, what we should be able to do is start up, and then we'd have this user service gRPC blocking stub. Each one of there's also an asynchronous flavor of these stubs, and also you can stream. I just chose the simplest blocking stub for the demo purposes. Okay, so let's create a user controller. And we'll do, let's see. A little bit of cheating here. Okay. And all this is going to do is basically we're going to inject in that blocking stub that we configured, and then from that point we're going to just curl this user endpoint so that we can actually make a remote call using the stub. And at this point we should be able to run. Where did I go here? All right. Wait, it's complaining about something. Oh, yeah. Okay. So here, yeah. So it looks like it's up and running, and yeah, running on Tomcat port 8080. So let's come over here, and now we should just be able to curl that client app. Yep, and you can see it went through and hit the client app. The client app came over here, and using that stub, the client stub, made the call to the server. If we look over here on the server, you can see that it got the call from the remote client app. Pretty basic stuff at this point. And so let's show how to hook into the health system and how the clients will actually respect the health of the server. So I'm going to stop the server. This is the server right here. I'm going to stop it. I'm going to go back over to our Spring initializer, and I'm going to add in Rabbit. I'm going to add in Docker Compose. And the reason I'm doing this is I want an easy way to have something hooked into the health system on the server side that we can shoot and then see it stop and get once it has the health status is down, then the client will respect that. Okay, Spring, Docker Compose, and Actuator. Okay. Let's explore this. And what I'm going to do is copy this POM file, and I'm going to put it in here. Okay. So, and then one more thing I need is this compose file. So if you haven't, I'm not sure if you've used it. So Spring Boot has support for Docker Compose. So anytime that you're an initializer and you pick, say, Pulsar or Kafka or Rabbit, it'll generate the Docker Compose file, and it makes it really handy for development purposes for sure. And so here we will do new file compose.yaml. Okay. And so what this will do now is when we start up, it'll bring up the Rabbit Docker Compose up, and then we'll show that the health indicator is green, and then we'll stop the Rabbit service, and we'll show that it's red, and we'll show what the client does. Okay, so what else do we need to do? Let's go over here to application properties. We do have to tell it which health indicators we want it to the service to pay attention to. So if we say Spring gRPC.server health actuator enabled true, and then health indicator paths Rabbit. Yep. So I think that's all we want to do here. Let's run it and see what happens. What it's doing is probably, oh, run. Okay, so it didn't. Let me see. Probably need, oh, yeah, let's rebuild. Okay. Oh, yeah. I thought the rebuild would do it, but yeah. Now let's try. Yeah, there we can see it's bringing up Docker Compose, or you see Rabbit coming up, and wait. Server 8080. What was on 8080? Why is it? Okay, so let's do this. Okay. Let's come back over here and run. Oh, no. Okay. There we go. So it's up and running. And if we go here, you can see that Rabbit's here running. You can also see we have our Rabbit indicator right here. It's green, right? And so I'm going to go back over here to this client, and let me set the server port to something else. $7070 user. You guys also got to configure it so that tell it that you're interested in using the health check. So at this point, I'm going to start this back up. Yep, and so now it's back up and running. And so if I come back here to curl, not found path. Yep. Perfect. There we go. Maybe not. It is 7070, right? Client about to register. Okay, for some reason, let's see. Health. Your channel is user, address, static, localhost. Oh, Let me look at something here. Oh yeah, because of the this right here. gRPC says Rabbit Spring Boot Starter. I'm gonna just so what it did is because it saw that it brought in the server web Spring Boot Starter I think because of Actuator. What happened is it automatically switches to running on the servlet container. That's the thing I wanted to show afterwards. But let's do this and say gRPC server servlet enabled false. Okay. Now let's stop this. Okay. And so what is it doing here? Same thing. Okay. It's back over here. Attempting to connect to. Did it still run on Tomcat? Or? Yeah, it did it again. Let me see. Yeah, 88 again. Okay, well, we'll just do that. Let's switch this over here to, okay, gRPC server 8080. So, server enabled false, client channels health 8080. Okay. Let's try that. Okay. What? Network closed for unknown reason. Okay. No, not that. Client about to register, server code. Okay. Let me do something here. Let me just take this off. Tomcat 8080. Okay. Okay, gRPC curl is fine. So now let's go back over here to okay, I don't know what's going on here. So let's see this. I guess the thought of having two separate processes turned out to be not simpler. There we go. Okay. So now, great. At this point, we're back to where we started. We're communicating remotely, client server. Now, this is the whole point that what I was trying to show was if we come over here to Docker Compose, and we now stop this, there we go. So it's not running any longer, and you can see that the health has gone. Should go red here in a minute. There we go. Grab it. There we go. So now the health indicator's down on the Spring Boot actuator. And so if we come back over here to our client, now whenever we try to invoke this, it'll fail like it was before, but this time for the expected reason that we were trying to show is that now it returns back, hey, it's unavailable. The health check service responded not serving. And so if we come back over here to that and restart it, and I'm going to restart the service because the port changes and didn't pick it back up yet. Okay. Now if we come back over here, yeah, we're back to there. So that, it's nice that the client actually hooks in, and this is all part of gRPC Java. There's a load balancer that the clients use, and it takes part of that health. If you tell it to use the health system, it'll use the health system. The other thing I wanted to show was running in the servlet container, but we're already running in the servlet container as part of the dependencies. If we come over here to, this is the demo client. Let's go to the service. If we look at this POM, yeah, there is, oh, it's on the console here. Well, we already showed that it was running in Tomcat, but that's, it'll run in Netty by default, but if you have if there's Spring Webs on the class path, it'll run in Tomcat. And I think we have, we'll go in, I think that's it. That's the end of the demo there. We'll leave some time for questions. Cool.
Now, did you have to write a web client code, or did this stuff take care of that for you?
One more time?
Did you have to write a web client code, or did this stuff take care of that for you?
No, yeah, I didn't. The stub took care of it. Yeah, I didn't have to do anything other than that original implementation of telling what that method to do. Yeah. Yes. Mm-hmm. Yes, and so so what we do is if you're using Netty, it already has it has built-in MTLS support, and I think by default what we do is we also implement basic authentication. You can also, if OAuth's on class path, it'll use OAuth as well, but it's done through the interceptors, the same thing. So on the client side, you can set up a global interceptor and pass in your token, and then on the server side, similarly. Yep. And we have two interceptors built in that you can hook into, and one's for basic, and I think the other one is OAuth. So I wanted to demo some security stuff, but I figured I'm glad I didn't add any more stuff to the demos right at this point. So yeah, but it is easy to use. Yep. Any more questions? You can, we also have the concept of customizers. So this is, if there's anything that's being auto-configured and you need to extend it or slightly modify it, most of the components have customizer beans that you can provide to adjust them. And there's also a handful of Spring Boot properties, the Spring configuration properties that you can use to configure the app. Cool. All right. I think we can. Guess we can end a few minutes. Yes.
So, the EA for getting you to
getting 1.0. So we're shooting for Spring Boot, the release coming up in September, Spring Boot 4, and worst case scenario would be in 4.1, but we're shooting for 4.0. And I think even if the auto configuration doesn't make it into boot at that time, I think we're going to do a 1.0, I think, regardless at that point at September timeframe. Yeah, because we've been for about a year now, we've been going from 0.1, 0.2, 0.3, and people are using it, and it's out of experimental, but it's in this weird pre-GA kind of state where a 0.1 is not a version number, is not some 1.0 feels better to use than 0.1, 10. Well, I guess if there's no more questions, we can end early.